All right, we're back with part 2 here. Example 1, we've got a diagram of a circle and a bunch of lines and stuff like that. And we just need to state some stuff. So what sort of stuff? Well, given the diagram, state a chord. And there are lots of right answers, right? We just are getting used to these terminologies. And a chord is a line segment joining any two spots on the a line segment joining any two spots on the circumference. So AB is a good one. A major arc and minor arc. Well, an arc we know is just a piece of the circumference. What the difference is between a major arc and a minor arc, a major arc is more than half the circle. More than half circle. And what the heck do I mean? Well, notice AB is an arc. I could say that's an arc. But that's not more than half the circle. This way is also an arc, AB, isn't it? AB this way is a major arc. So AB is a major arc. And sometimes you throw an extra letter in there just so that you know whether it's a major arc or a minor arc. But major, we think of the big way. It's the long way home. It's the long way home from A to B. Minor arc, then we just say minor arc AB. And there's lots of choices, right? BC is a minor arc, the one that I've listed there. DC is a minor arc, but it's also a major arc because I could go around the other way. So minor arc DC, we know what that we're talking about, that one right there. That's a minor arc DC. A radius. Well, there are a few candidates here, but any time I start in the middle and go to the outside, we've got a radius. And that one's we're familiar with. The only diameter here is AC. I suppose we could have said CA. A tangent. A tangent is a line that touches the circle only at one spot. Right? EF is a tangent. And the line through EF. EFG. A central angle. A central angle is any angle at the center of a circle, and there's a few candidates here, like AOB is one. Angle AOB. And that little symbol, by the way, it's supposed to be like that, but that looks a lot like my C's and my L's. So that's why I put a little arc in there to show that it's an angle. Angle AOB. A secant. Well, sheesh, I've forgotten what a secant is. Let's go back to the diagram and look. Secant, secant, secant. Oh, it's not even in here. What's a secant? I don't know. A secant is kind of like a tangent, but it cuts it in two spots. It's kind of like a chord that keeps going. So a secant is a line that cuts in two places. ED is a secant. A sector. A sector is like a piece of the pie, right? It's an area. So there's a few of them there. Even like a half circle here. This piece here would be called a sector. This half circle. But that one right there is easy to refer to because it's got a Y on it. Sometimes we would call it by its letters BOC, the angle that defines the sector. Sector BOC. An inscribed angle. An inscribed angle, remember, is one that's got all 3 points on the circumference of the circle. Let's see how many. That's a central angle. Where's one? Aha, here we go. BAC. And that right there is an inscribed angle, isn't it? BAC. A segment. What's a segment again? Well, let's look back on our diagram. A segment is the area inside a circle enclosed by an arc or an arc in a chord. So that's right. It's kind of like if you snipped off a chunk. This is a segment here, X. Good. Let's go on with example 2. In the diagram above, well, I think I'm going to have to copy this diagram. You've got it right with you. I'm going to have to copy it here. Let me just copy that and put it on the next page as well, just so I have a copy. I'll have all my messy writing on it, unfortunately. Okay, so the length of minor arc AB. The length of minor arc AB, this one right here. Well, we were kind of figuring out this stuff before. AOB is 95, so then the length of that arc is just the fraction. It's a fraction of the circumference, right? Fraction of the circumference. Circumference is pi d. Now, what fraction is it? Well, it's 95 degrees over all the way around, which is 360. So this is 95 over 360 of means times pi times the diameter. Now, how long is the diameter? It says that's 6, so that must be 6. This is 12. And then I can bash that into a calculator. And I got, or I get rather, 9.94 centimeters. That's 9.94 centimeters long. The length of major arc BC. Well, I'm going to do the same calculation and mark up the diagram. Major arc BC, this is minor arc BC, so major arc BC is around this way, right? That's major arc BC. If that's 95, this little angle in here is 85. So what's this angle that defines the arc BC? Well, it's going to be 360 all the way around. Subtract 85, which is how much? 275. And again, it's just a fraction. Arc BC is 275. A fraction of the circumference. And I bash that into a calculator, and I get about 28.8 centimeters. The area of sector Y, well, we've done this too. A sector, this blue bunch in here, is just a fraction of the circle. It's not a quarter and it's not a sixth, but it is a fraction, right? So Y is equal to a fraction. Well, what angle was that? That was 85 degrees over 360. And fraction of times the area. R was 6. Bash that into a calculator, and you get 26.7 centimeters squared, about, and that's that area there. Now, the area of a segment is just plain old good clean math fun. We'll see. So this segment here looks pretty harmless, right? Well, how would we calculate that area? I'm going to clean this up as much as I can now. And I still got the other stuff from the previous question here, but I want to find this area right in here. Well, can you see how it's a sector subtract that triangle right there? So a segment is just the area of a sector subtract the area of a triangle. Now, as it turns out, this is actually pretty hard. The sector isn't bad, and I'm going to do the calculation over here. The sector is just a fraction of the area. It's, what did we say that was? That was 95 degrees, right? 95 over 360 times the area. That's the fraction of the circle that it is. R was 6. And that sector area was, looks like 29.8. If you use a calculator. The area of the triangle. Now this is actually pretty darn hard. The triangle, hang on, that's not that hard. It's just base times height divided by 2. But we don't have a height in here, right? We could say that's the height, right? But we don't know what this is. and we don't know what this is. That's a bad choice of height. What we're going to do is we're going to think of, and I'm going to need some room over here because I'm running out of rough space here. I can only imagine you're running out of rough space too. I'm going to think of this triangle this way. I'm going to rotate it just a little bit. O is here, B is here, and A is here, right? This is 6, this is 6, and my height is actually over here then, isn't it? This is the height, because this is 95 degrees. Well, how do I find that height? It's hard, but it's trig, believe it or not, right there. That angle is 85 degrees, right? Because it has to add up to a straight line. And this is the opposite side where the hypotenuse is 6. So I've got the opposite in the hypotenuse, and that's equal to, opposite is the sine of 85 degrees. So opposite's what we want to find. Hypotenuse is 6. Note to self, study for the exam. Oh, this is kind of like studying for the exam. I multiply 6 times, cross multiply 6 times the sine of 85 is 5.98, and I get the height. Where am I going here? The height here is 5.98, and this is, the base is 6. The base is 6, the height is 5.98, divided by 2, and I get an answer, 17.94, and then I can calculate the segment. What's funny about this, folks, is our book, the little blue books, have a formula for the area of a segment, and it's all in here, but I think it's just as easy to calculate it. And then I go that the sector subtract the triangle, and I get 11.86. I think we're going to have a course record by a third part to this video. So I'm going to pick up the last piece, and it should only be about 4 or 5 minutes. In part 3, oh my God, part 3! I can only hear the complaining starting right now. Part 3 in just a second.